Welcome to a fascinating journey into one of the most profound and speculative hypotheses at the intersection of physics and biology: quantum entanglement consciousness. This isn't a recognized medical condition, but rather a theoretical framework attempting to explain the enigmatic nature of consciousness itself through the lens of quantum mechanics. Today, we'll explore what this hypothesis entails, its proposed mechanisms, and the ongoing scientific debate surrounding it. Before diving into quantum entanglement, let's briefly touch upon consciousness. What is it? The ability to be aware of one's existence, surroundings, thoughts, and feelings. Despite millennia of philosophical inquiry and decades of neuroscience, the hard problem of consciousness, how physical processes in the brain give rise to subjective experience, remains one of science's greatest mysteries. Traditional neuroscience largely focuses on classical electrochemical signaling between neurons. To understand the quantum consciousness hypothesis, we need a basic grasp of quantum mechanics, the physics of the very small. Two key concepts are crucial: superposition and entanglement. Superposition means a particle can exist in multiple states simultaneously until measured. Entanglement is even stranger. Two or more particles become linked, sharing the same fate regardless of distance. Measuring one instantaneously influences the other, as if they are non-locally connected. The most prominent theory linking quantum mechanics to consciousness is the orchestrated objective reduction, or ORC-OR theory, proposed by physicist Roger Penrose and anesthesiologist Stuart Hameroff. They suggest that consciousness arises not from classical neuronal firings alone, but from quantum processes occurring within protein structures called microtubules, found inside neurons. According to ORC-OR, consciousness emerges from orchestrated objective reductions of quantum superpositions within these microtubules. They hypothesize that quantum coherence and entanglement can be maintained within these structures, allowing for a unified, non-local information processing that gives rise to our subjective experience. This objective reduction is proposed to be a self-organizing process that collapses quantum states into classical ones, creating moments of conscious awareness. Unlike medical conditions, quantum entanglement consciousness has no observable signs or symptoms in the clinical sense. It's not something you have or don't have. However, proponents suggest that if this theory were true, it might offer explanations for phenomena like the unity of consciousness, the rapid processing of information, or even aspects of intuition and creativity that are hard to explain through classical neuronal activity alone. It's a theoretical framework, not a diagnostic entity. Diagnosing or even experimentally confirming quantum entanglement consciousness faces immense challenges. The delicate nature of quantum states, prone to decoherence, loss of quantum properties in warm, wet biological environments like the brain, makes direct observation incredibly difficult. Current neuroscience tools are designed for classical electrical signals, not subtle quantum phenomena at the sub-nanometer scale. Research is largely theoretical and computational, seeking indirect evidence. The scientific community's response to the ORC-OR theory and quantum consciousness is largely skeptical. Critics argue that the brain is far too hot, wet, and noisy to maintain the necessary quantum coherence for long enough to be relevant to consciousness. They point to the lack of direct experimental evidence and the successful explanations of many cognitive functions by classical neuroscience. However, a small but dedicated group of researchers continues to explore these possibilities, pushing the boundaries of our understanding. As quantum entanglement consciousness is a theoretical concept, there are no medical treatments for it. However, if such a theory were ever proven, its implications would be profound. It could revolutionize our understanding of consciousness, the mind-body problem, the nature of reality, and even the potential for artificial intelligence. It would open new avenues for philosophical inquiry, ethical considerations, and potentially even new forms of quantum medicine or brain-computer interfaces, though these remain highly speculative. In conclusion, quantum entanglement consciousness is a bold and imaginative hypothesis that seeks to bridge the chasm between the strange world of quantum physics and the mystery of subjective experience. While currently lacking empirical verification and facing significant scientific skepticism, it continues to spark debate and inspire researchers to think beyond conventional paradigms. It reminds us that the universe and our place within it may be far stranger and more interconnected than we can currently comprehend.